The last thing I wrote was uses less electrolyte than a flooded batteries, or than flooded batteries. Not than a flooded batteries, that's not proper. But then Zach helped me out, and he put point number 2, gel batteries. So we just had the glass mat, absorbed glass mat, and now we have the gel battery, or also called a gel cell. Thank you, Zach. With the point of electrolyte. What about the electrolyte, Zach?
It's there.
It's there. Is contained within, nope, wrong point. Something about electrolyte. Electrolyte, just got to scroll down, is mixed with silica to create a gel. Electrolyte is mixed with silica. What is silica?
Material. Ask Hollywood.
Hollywood is spelled S-I-L-I-C-A-S-A-L-I. Is silica. What is silica?
That's just stuff they pump you full of, so you wouldn't nice.
Stuff to keep your stuff dry. Yes.
That's not silica. That is desiccant. To create, why can I not? A gel. Really? I don't have anybody tell me what silica is. What's silica?
Well, so silica dust, like aerogel, that really they use it in as heat, like heat protection in spacecrafts. And
Okay.
everything. It's super.
Generally speaking, what is silica?
You ever buy that stuff? You ever buy a product and it's got one of those little packets in it? Yeah,
It says do not eat.
Yeah.
Those are delicious. Silica gel or desiccant. I think it's silica. Anyway, silica, and the reason why I'm kind of saying what is it, is because as an aircraft mechanic, it comes up all the time on oil analysis. So if you have an oil analysis done, which most people, or a lot of people do, you have a high silica content. You need to know what is silica, where does it come from? Well, it's a little bit different maybe in this case, but it would be funny if it was the same thing. But it is, what is sand?
Sand is
Rocks. It's rocks chewed up by fish that poop it out and make it.
Great. Then I'll just tell you, if you have a high silica content, you have a high dirt content in your aircraft engine. Where do you get the dirt from?
In the air?
From the atmosphere. It's dirt. So they're mixing this stuff with dirt, and then you get a thing. You get a gel. Just mix with dirt. So yes, if you have a high silica content in your oil analysis, you have a problem with your induction system. You have leaks, and you're getting silica vessel. Okay. Let me see. Okay, we're back kind of this way, so it's V, which would make I. Somehow, I don't know why that is. Oh, I know why. Okay, that makes sense. Okay, sealed batteries. Sealed battery, and I wish my friend Joe knew this one. Sealed battery. Sealed batteries are not serviceable. Are not serviceable. Now, I got to be careful how I say this. S-E-R-V-I-C-E-A-B-L-E. Because serviceable can mean two things. Cannot add water. Which maybe I should have just said you can't add water, because we use the word serviceable in aviation to mean good. Is this part good? Yes, it's serviceable. It's it's like another way of saying acceptable. And I don't mean to say that sealed batteries are not something that you can work on per se. You don't just take it out of the airplane and carefully set it on not the concrete and put it back in. In fact, quite the contrary. When I first got into aviation, there really wasn't much we call it instructions for continued airworthiness, ICAW, instruction for, and so there wasn't it became a big thing, I don't know, somewhere in the late 90s, where everything was like, oh, we got to start having ICAWs for everything. Because what was happening is you have an airplane, comes out of the factory, and has a manual. And the manual tells you to work on the airplane. But then you do something to it that is a supplemental type certificate or a modification, and then there were no instructions to go with it. So the next mechanic down the line would say, well, I don't know what to do with this. You modified it, and there's no instructions for what I'm supposed to do every year. So now there's ICAW for stinking everything. I put it's called I forget what it's called, door minder or something like that, door steward on my aircraft. It's just a gas strut that when I pop the door open, it opens it up and holds it open on its own. Well, that was a supplement to the type certificate. There's instructions for continued airworthiness. Every year you're supposed to read it and you're supposed to inspect the gas strut. So anyway, but batteries didn't have much of anything. It was just some 4313 acceptable methods, practice, techniques, some textbook stuff. What I told you, check the water level, wipe it off. It's good enough, put it back in the airplane, right? But now when you buy a battery, even for the small planes, it's going to come with an entire manual, instructions for continued airworthiness, and I don't even know if I made it in my notes, but one of the big things you do every year now, it's right in there, is you have to do a measured discharge on the battery. So you've got to take it, you've got to, you do an inspection on it, you have to verify its charge, and then you do a measured discharge, just like you're doing with that, you guys that are now doing it with that one Ni-Cad battery. You have to do that with the lead acid battery. So you're going to put it on some sort of discharge machine like we have, and you're going to do the measured discharge. You guys saw me doing mine. I did not do mine here at school, but you saw me do it. And then you have to follow that. If it's good, you can put it back in service. As where before, it was just, how do you know your battery's bad? Well, you turn the key and it doesn't work, which is really bad because according to the federal law, you have to have 30 minutes minimum of battery power. So if you have a battery that hasn't been inspected, you don't know that you have 30 minutes, which also brings up another subject that I'll talk about, but I'll say it now, is can you jump an aircraft battery like a car? Yeah. You go in there, you try and start it, and it won't start. And so you call for line service. Line service comes out, they give you a quick jump, you start the airplane. Like my airplane has a receptacle around the side, so you can just walk, it's not far from the prop, thank you very much. But you can plug in a ground power cart, start the airplane, pull that, and see you later, it's running. But I had a dead battery, and I take off. Do I have 30 minutes of reserve on my battery?
No.
So I'm violating the FARs right there. So if anything should happen, then I'm in big trouble. So, all right.
Basically, you're just saying get a new battery. Legally.
No, charge it, service it.
Is that why? Because if you're let's say you're in flight and your alternator's doing all the legwork, but then your engine dies, then you lose all your communications basically.
Yeah, you would. Yeah, so right about the time you really need to communicate with somebody and say, Mayday, 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 you just lost alternator, you had no battery, so your radios are just shut down, and you're like, wow, this just really turned from really bad to really, really bad.
The King Airs, the ground plug is not that far from the top.
Wonder if they do that so you don't use it.
Yeah.
Okay, so, oops, just two eyes. Let's see, use caution. So we're still talking about sealed batteries. Use caution when charging. When charging. Charging due to. There was at first a lot of issues with these batteries. In fact, they only wanted you to use very specific chargers because if you overcharged it, you warp the plates. You warp the plates, then you get a short and it's no good. So, battery's inability to vent. So if you have a battery that's not going to vent and you're going to put 40 amps into it, you're going to have a problem. So, and inability to add water. And if it does gas off and spill water, well, you're kind of out of luck there. All right, so this is G, way off to the left now, operating theory. All right, I may not, let me see. What I have written here is long. It says the actual chemical process that occurs is beyond the scope of this class and not relevant to your job as a mechanic. However, the result of the chemical action is important. So I'll put that result. The result of the chemical action is important and it is relevant. So, let me see, 5, 6. Let's do this. Watch this video. After this,
The increasing amount of technology we rely on in everyday life makes portable energy sources essential to our world today. We can power our cell phones and laptops with lithium-ion batteries, run flashlights from alkaline ones, and many of our watches depend on batteries constructed with silver oxide. This one, though, may be the most important of them all. Now, I know it seems a clunky, old-fashioned thing. It was invented in the 19th century, but it still makes our world move by starting our cars, motorcycles, and trucks. No wonder it's the best-selling battery. If you understand how this battery operates, you can grasp the principles underlying any of the newer ones and even see why no single type of battery can be used in all applications. Let's take a look inside. The first thing to note about this motorcycle battery is that it's heavy. That's because it's tightly packed with lead and lead oxide sheets, both of which are very dense. This is a cell from an identical battery, and you can see the lead, and underneath this, the lead oxide. They alternate throughout the interior. So let me show you how they store electricity using just 2 plates. So I have here a lead plate and a lead oxide plate from the battery, and the sulfuric acid, and now watch what happens when I connect the leads. The LED lights up. A current flows from the lead oxide cathode to the lead anode. The lead gives up electrons which the lead oxide accepts. This exchange turns both plates into solid lead sulfate. Now, let me measure the voltage difference between the 2 leads. And you can see that it's about 2 volts, which means that to make this 12-volt battery, 6 cells are linked in series to make up the 12 volts. So that's the basic electrochemical reaction. Now let's look at how you engineer a battery. We want a battery to have a high density of either energy or power, and that difference being that batteries with a high energy density can store large amounts of energy and release it reliably over long periods of time, whereas batteries with a high power density release large amounts of energy quickly. This battery was designed with power in mind because we need a burst of nearly 400 amps to start a motorcycle. To save space, we need to pack the plates in here tightly, but in order to ensure that the electron transfer takes place through the terminals, the plates are mechanically separated by these permeable layers. Now, let me show you 2 plates from a discharge battery so you can see the effect of a deep discharge of a battery. If we look at these 2 plates, we can see the effect of a long-term discharge. This light coating here is lead sulfate. That explains why if you run a car battery to 0 charge a few times, you're likely to kill it. As the battery discharges, lead sulfate takes the space between the plates. If too much builds up, you'll never be able to recharge the battery. This highlights how every different application needs a different type of battery. You see, with most engineered objects, there are going to be trade-offs, giving away some characteristics you want to gain others that you must have. Indeed, the toughest part of engineering often ends up being balancing the trade-offs in a design. For example, a car battery does a great job starting a vehicle, but not running one, like an electric car. Nor is it a good candidate to store energy from solar panels in a house. There, we harvest energy from the sun, charge up the batteries, and then use the stored energy in a variety of ways until the batteries die, and then recharge them with the sun's energy. For this use, we would use what is called a deep cycle battery. As the name implies, this battery's capacity can be largely used and then recharged easily. To convert an SLI battery, like used to start a motorcycle or a car, into a deep cycle battery, we do 3 things. We use thicker electrodes to increase energy density, space them further apart so lead sulfate debris can fall off of them, and add room below where that debris can accumulate. The trade-off is that it's larger, heavier, and gives off a lower current than a car battery. It would seem that we'd want to get rid of the lead-acid battery. It poses a significant environmental risk if disposed of improperly. We still have the 19th century lead-acid battery because of what nature has handed us. Plentiful electrode materials, lead and lead oxide, both very high in conductivity. Once we arrange these materials correctly, we have a cheap battery with a high power density. No other materials found in nature meet these criteria so well, which means that with current technology, it is extremely difficult to overcome this barrier. That's why 19th century technology is still the go-to for starting our cars. I'm Bill Hammock, the engineer guy. This video is based on a chapter in the book, 8 Amazing Engineering Stories. The chapter features more information about this subject. Learn more about the book at the address below.
I like that guy.
Because you're the one doing it.
You're the switch guy.
Uh-oh.
Uh-oh.
Video is unavailable.
Private. What are you
Private
trying to
now.
show us here?
Was
All kind of chemicals.
chemical process inside a Bosch battery. Let's see. Playing YouTube roulette. Yep, that's it. Write all this down. Never mind.
Hey, Kevin,
Good video.
I got a question. Is,
Yeah.
Is the FFA like set standards? Because I know like
These are the people that
Nature Farmers of America.
yes, these are the people that regulate cows and sheep. Do my best, but
no, but are they setting standards? Because I noticed a lot of airlines are starting to go electric, and I know like we're going to be phasing out gas cars. Are they going to do the same thing with airplanes?
FAA, that's not their business.
I know, but I mean, I'm just wondering because I know the government's trying to do this whole green initiative.
Well, that would, this is my opinion, I don't know. I think the government would come out in a different way and not through the Federal Aviation Administration, but probably just say something about greenhouse emissions that would force airlines to do something that wouldn't necessarily be part of the federal regulations, and I don't know. But remember, airlines, they're here for a profit, and so they're going to be looking for how they can be profitable. So I don't know. I think they do make emission standards for engines and such.
So, I think it's ICAO is pushing it.
Yeah, but that's not a
ICAO
government
pushing it,
regulation.
Plus, airlines are going on their own path for that one. A lot of airlines of United are funding electric aircraft or lower carbon fuels.
Yes.
On top of that, Boeing is putting out a lot of subsidies
Okay.
for electric.
Back to this. This is, and if you're watching online right now, you won't be able to see all my notes on the bottom because I'm right there. But anyway, this is basically what we just watched. That's why I stopped. I'm like, I got it right here because I didn't realize how hard it was to watch that. But how a lead acid battery works. And it's okay if you don't write this down because, like I said, the actual process of what's going on is not as important as the result. So a battery converts chemical energy to electrical energy. The positive plate called the cathode, the negative plate called the anode. Again, I'm not going to hold you to that. You have electrolyte, 70% water, 30% sulfuric acid. And there we go. The cathode is made of lead dioxide, the anode is made of lead. And notice that even amongst, well, we just watched that the one video, and he started with lead and copper, and then a second into it, it was lead and spongy lead, and so I'm not going to hold you to those materials either because you can see they kind of change. During discharge, sulfuric acid, which is important, breaks into two parts, the hydrogen ions and the sulfate ions. Sulfate ions combine with the lead plate and form lead sulfate, giving up their negative charge, which gives the lead plate more electrons. Yeah.
So is the lead dioxide basically just a rusty piece of lead?
Yeah, I was gonna say.
Sure. Okay, so things to note. The sulfuric acid, which is the what? Electrolyte. Okay, it's breaking down into two parts. And also we want to note the word lead sulfate. So he talked in the previous video, he talked about lead sulfate. Where does this sulfate building up on?
The plate.
The plates. That's very bad. So if you leave a battery in a discharged state, it builds up lead sulfate. Can you get the door for her? And that doesn't want to leave the plates. And so it renders, like, consider spots on the plates unusable.
Why is it only when it's low? Why is it only when the battery's drained? Is it
It's because of this chemical process. So if we really wanted to, which I don't want to focus in on this, but if you, yeah, you did, you would see that's what it.
Sorry,
No, it's fine. But but we hear the sulfate ions combine with the lead plate and form lead sulfate. This is during discharge. So during discharge, you get this sulfate ions combining with the lead plate, which forms lead sulfate. That's part of the discharge process. All right. Let's see. Lead. Okay. The hydrogen ions combine with oxygen and lead peroxide, forming water. So what's happening to the electrolyte as it's discharging? It's becoming water. Okay, it's going from this acidic towards water. So this process takes electrons from the positive plate, making the plate more positive. The lead peroxide combines sulfate to create lead sulfate. Again, to create lead sulfate that's bad, on the positive plate. The combined chemical reactions is the plus plate has a deficiency of electrons, while the negative plate has an excess of electrons to supply power. Let's see. During discharge, the chemical... Was that during charge? I'm sorry. Should have been. No, it's during discharge. During discharge. The discharge chemical reaction will continue until the load is disconnected or a charging current is applied. So remember that in an aircraft or car, vehicle of any type really, that the battery, while you're starting the vehicle or before the engine is running, or the alternator, if you will, really, the battery supplies the power. But as soon as the engine is operating and the alternator is turning, and the alternator is now charging the battery is a load, no different than a bright light or resistance heater or something like that. It goes from being power source to a power drain. And in the aircraft, you have an amp meter that goes from 0 to positive 40 to negative 40, if you will. It can be, those numbers can be as much as you want them to. And so when I'm in the aircraft and the engine is not running or the alternator is not on, because in an aircraft you actually have a switch where you can turn the alternator generator on or off. So I can be running the engine with the alternator off, unlike your car. Then I can flip. So let's just say I've done that, I've for whatever reason, or I'm just sitting in the airplane. I decide, hey, I just want to abuse my battery, so I'm going to turn on the master switch. Engine's not running. I decide that it's a little dark out. Well, I just turn on my landing light, my taxi light, my wingtip lights. I'll put the strobe on, and then turn on the radios, and I'm just using every electrical load that I possibly can. If I look over that ammeter, it's going to be swinging hard negative, and it shows me how much power is leaving the battery. All right. Then I say, I better start the engine. So, hopefully you turn off your loads, and then you start the engine, you bring them all back on. Turn on the alternator, and you're going to see that ammeter swing hard to the positive side. Well, it's actually this way for you guys. The positive side. It's going to swing hard, and let's say it goes to 20. Right? That's how many amps are going into the battery, not how many amps I'm using through the whole aircraft. And you're going to watch it. It's going to slowly go down till it's almost at 0. Now, if I'm using landing light, taxi light, every load I have on the airplane, and the ammeter says 0, what is that telling me?
The alternator's providing all the power for all that stuff.
Yeah, it's just telling me what goes in and out of the battery. So if it's at 0, it means the battery's charged and it's pretty much happy. So, all right, charging current is applied. The reverse chemical process, let me see, reacts to the lead sulfate to reform the sulfuric acid and lead. So we get rid of the lead sulfate when it's charged. Battery is now full. Electrons have been converted to chemical energy. All right, so, I like that. Continuing to charge the battery after it is full or applying too much charging current will cause the water to break down into hydrogen and oxygen. Hydrogen and oxygen bubble out of the electrolyte and form hydrogen and oxygen gas. What do we get with hydrogen gas?
Hard smell.
Boom.
There. Hydrogen gas. Remember the Hindenburg? We were there. Come on. I said we. The humanity. What? Too soon. Oh, it was a blimp. It's a real picture, a blimp. And so hydrogen gas is very light. And so they had, the Germans, right? The Germans had built this blimp, and it came all the way over the Atlantic, right? It was here.
Yes, yeah.
And so they made it over the Atlantic, and they were coming into land, and they had all these TV crews filming. It's all in black and white. And it's kind of a controversy to this day, but it's believed that it was static electricity because they used, in fabric-covered aircraft, you use aluminum pigmented paint. It's a dope. That's what they call dope, but it's aluminum kind of crushed up into this paint, and you paint it on, so it gives it UV protection. Well, it's aluminum, so it's conductive. So there was a spark. The spark ignited the hydrogen, and right there on camera, the whole thing burnt, and everybody crashed and died.
Yeah, it lit up in like a second and a
Yeah.
half. It was gone.
That was a crazy.
I kinda wanna see that though.
It's sabotage.
I've never, someone blew it up. I don't think it was the hat.
Hey, I'm like, how old is it? Huh? How old is it? Teen?
Someone blew it up.
Someone blew that up. Teen, man. I remember when they were
She just did this to shut me up.
The ill-fated Hindenburg on her last flight sails over New York. These pictures, made from a Pathé News plane less than 4 hours before the tragedy, show the world's largest airship heading for Lakehurst, New Jersey. Over Newark's famous Auto Skyway, the airship was hailed by thousands who little dreamed it was their final glimpse of the Hindenburg. Inside the silver envelope are 16 separate gas bags, each filled with hydrogen, a highly inflammable gas.
Yes, that is a swastika on the back. Please don't call and have me fired because I showed a video that contains a swastika. It's just-
From the ground, you can see the forward
Germans.
control cabin
It's World
from
War
which
II.
the ship is operated. The windows along the side indicate the location of the passengers' quarters, in which many were carried to a flaming death.
right there, right? Passengers.
Approaching Lakehurst, the Hindenburg appeared a conquering giant of the skies, but she proved a puny plaything in the mighty grip of fate. It almost seemed as if fate had set the stage for the horrible tragedy. A graceful craft sailing serenely to her doom. For 3 hours, the dirigible circled the landing field at Lakehurst, New Jersey, dumping more water ballast than ever before in vain efforts to level off. Again she dumps ballast, and a nervous tension grips those who are watching, for this is something unusual. There goes more ballast, but the tail is settling in spite of all that has been dumped. A grim note of impending tragedy. Finally, the landing lines are dropped. These scenes were filmed by Pathé News cameraman William Deek, and you are about to see the pictures he got when the ship exploded. Those aboard leaping for life from a flaming inferno. The actual crash of the Hindenburg. An airship destroyed in less than half a minute. Rushing to the rescue, the heroes of the tragedy dash in, heedless of danger, to help the injured to safety, while others, beyond help,
There you go. It's Hindenburg.
Bright-eyed view is the build a flying bomb?
Why would they use hydrogen gas if they knew about it?
Because they didn't think it would explode. It's contained in a gas bag, so.
There was actually like one of the best, like, like everyone marveled at how
Yeah.
great of it was, super efficient, like, yeah.
It was the Titanic of airships.
It was.
It was like the best.
Look at the motors on it.
It was the best. Tell it wasn't.
Okay, let's see, what do we got? All right, so a couple, like I said, the operating theory isn't as important as the result. So what is the result? So let's see if I can. Lead sulfate forms in a discharged battery. And what else? Lead sulfate and lead sulfate is highly resistant to current flow. Current flow. That is bad if you're just joining us in a battery. So leaving a battery in a discharged state will damage the battery. So don't do that. As a battery discharges, the electrolyte becomes more water-like.
Could we also just say more neutral?
So what?
More neutral?
No, that wouldn't mean something to everybody, but more water-like does. But you can say that if you like. So if I said more neutral, they would say, "What do you mean by neutral?" So that's why I pick my words. Okay. The state of charge. So if a battery, as a battery discharges, the electrolyte becomes more like water. So if that is true, which it is, the state of charge can be checked by using a hydrometer, or hydrometer if you like. Hydrometer is the proper word. So you get this lead sulfate that happens on batteries, and that's bad. And even a battery that is properly maintained is eventually going to have this problem. You get buildup, you get lead sulfate going, and they just wear out. And so there are things that people will do to try and regenerate a battery. Some of these things are you can buy, it's like they claim that they pulse into the battery to knock off the lead sulfate. So I have one right here somewhere. I forget what I did with it. We tried messing with it. It kind of worked a little bit on some really abused batteries. We got them.
Create another short if it comes down and touches them at the bottom.
It will, but you're hoping that it goes down to the bottom. So that's one thing that you can see them on the internet and stuff. And like I said, I found one in my office, and so we were playing with it. It didn't seem to do anything. And you can certainly hook it up, and it doesn't make a noise or sound or do anything. You have to hook it up to a oscilloscope to actually see what it's doing on the electrical side of things. So you can do that. Some of the, what's the word, myths? No.
Urban legend.
Urban legends, yes. Things people do. People will often not so much these days, but take your battery out to the gutter and dump all the acid down the drain, which don't do that. And then, so now that you get rid of all the acid and get rid of that, well, all you got to do is just, and they would take it, and you got to be careful, but you drop it, and so that knocks off all the lead sulfate that goes down here. Then you take it upside down, you shake it, and you get all that lead sulfate out of the holes. And you can buy some new acid and then fill it up and then charge it. Now, if that's what you want to do for your lawnmower battery, other than the dumping it down the drain, I say have at it. But I don't think that's really an approved method for working with an aircraft battery. And when I say I don't think it is, I mean I know it's not. So, but that's what people do. And I was sharing with you yesterday or whatever about the charger that we had in our shop and paint room. This is a long time ago. Yeah, one mechanic, I mean, when the battery go bad, he did the equivalent of that, but what he would do is just clamp it on, and he would just crank the amps up, telling me it's just bubbling, literally bubbling. You can see a mist over the battery because it's just gassing. You can smell the hydrogen just pouring out of that room. And what he was doing is he was blasting the sulfate off of the plates, just giving it such a high amperage that it would actually kind of do that. And that would actually kind of work for a little bit after that. You also warp the plates and cause shorts and stuff like that. But, we come a long ways to, maybe the reason why it didn't work is because he would set it on the floor. He did. But we come a long way from, that being kind of the norm and that being considered the good mechanic. That's the guy you want to go to because he's going to save you a buck. Took it to this other jerk down here, man, he made me buy a new battery. I hate that guy. You got to go see Joe over here because, man, that guy, he knows how to save a battery. Going back to that till now, a good mechanic is saying, okay, it's time for your annual. I got to pull your battery out. I got to put it on a measured discharge. Some people don't like that still, but that's the right way to do things. By the way, in the manual, your battery manual, because you're thinking, well, shoot, how are you going to do that if you have your own plane and you're supposed to do measured discharge? I mean, who's got a couple grand to buy one of these battery, things? It says right in there, just get a load, get a known load and do it. Get a light bulb or something like that. It's not the big deal. The manual literally tells you to do that. There is, funny that this should come up tonight. One of the mechanic examiners in our area, Stash Air is his name. His name just went out of my head, but Stash Air, you can't forget that. Anybody know who I'm talking about? Shoot, not recording it. But anyway, no, but he's got this handlebar mustache thing, so it's kind of his gimmick. And his name will come to me shortly. Nice guy. But he is a mechanic examiner, and I follow him on social media, and he posts a lot of interesting stuff. You have to be careful because he also there are a lot of things I belong to on social media where people will post something that's like, can you believe I found this today? Or sometimes people actually post things like, hey, this is the repair I did. What do you guys think? And he'll take it and go, this is the worst thing I've ever seen. Don't be like this guy. So, but anyway, he posted something that I just ran across about batteries, and it's not a bad idea to follow this guy on social media because if you're going to, eventually you're going to have to take your exam, and it's kind of good to know what he thinks. Because he's the guy's opinion is going to matter at some point in your life, unless you have somebody else. Denny Pollard is his name. I don't know how that worked. But like I said, nice enough guy.
What's his social media?
Stash Air, like as in mustache, with a STACHE, Air, or something like that. So he actually just posted something about batteries. And he was talking today about, or in this post, about instructions for continued airworthiness and such. So at some point, you're going to be in front of a mechanic examiner and you're going to be given a battery project. And you need to understand what data to be using. And so, for example, and I would do this when I was a mechanic examiner, I would say, okay, I need you, and often what it was things I was working on in the shop. I'm doing an annual, now I got to charge a battery. Harry's my examinee for the day. I would say, we're going to charge this battery up. And we're going to do it in accordance with the proper procedures. And I would have the It came out of a Cessna 182. I have the Cessna 182 manual, the engine manual for the Cessna. I would have 4313. I would have a stack of textbooks, and I would have a manual that said Concord aircraft battery. And I'd say, we're going to charge up this battery. And which book do you want to go to? Came out of my Cessna 182. You got it. You want the battery manual. So you always go to the component manual whenever you can. Now, I say that, but you also have to understand that, like, I have a Continental 0470, and there's a Continental 0470 manual, and there's a Continental 0470 operator's book. There's also the Cessna 182 manual and the Cessna 182 book. This is confusing, but if the Continental manual, the operator's manual for my 0470 said, my red line is 2700, and my book for my Cessna says it's 2400, who wins?
The Continental manual. Oh, no. The Cessna manual, because that's the application of the.
It's the application. That's how it was certified. Cessna went out. They bought that engine. They bolt it to this airframe. They write that book. It takes precedence over everything. So it's confusing because they're like, well, wait a minute. What if the Cessna manual told you to do something with the battery, but the battery manufacturer said something else? Well, it can get a little confusing because you have to look at, is that the battery that it came with or a different battery? You know, like if I put a Concorde in, my airplane never came with a Concorde because its sealed batteries are a lot newer than my airplane. So, but the correct answer would be the battery manual. So his point was, make sure you pick up the battery manual and charge it in accordance with the battery book. Don't pick up the Cessna manual. Woo. All right, let's see. Wow. Okay, we can skip all of that page. No, we had those notes. Charging process. Obviously, a charging process. This confuses a lot of people. Well, maybe we'll just do a battery like this. What do you think about it? Just occurred to me that, all right, so we got the positive and we got the negative. Negative, we'll put that down there. Okay. And so which one do we disconnect first? All right, the negative. Okay. So now, of course, in an actual airplane, we've got a ground strap that's going to be bolted right to the airframe. So we got a little bolt that goes right through there and a little nut. And so there we go. We have the positive, and we're going to have big old fat wires going to go all the way up to a master switch somewhere. And so we can disconnect almost everything from the aircraft. By the way, there's usually, coming right off here, a little bus bar right near the battery with some fuses in it or circuit breakers. And that's going to probably go to the clock. The clock and what else is there? There's some other things. Hobbs meter. It's going to run the engine hours and stuff like that. But otherwise, we have a master switch, and the master switch is going to go to a bus, and that bus is then going to have all the loads going out, everything we can. So we have that, and one of these, let me think, what do we got? And off the bus, should do this. We also have a wire going to the alternator. So we'll put alternator. Alternator makes electricity, runs off the engine, right? Okay, so that's going to be grounded here. And so there's also a switch here, but we'll have it closed. All right, so when the master is closed and the alternator is not operating, we'll just do this to indicate not operating, and all of these loads are going out, the battery is being discharged. And it's going out to all of my loads. And oh, by the way, we'll just put a little ammeter right here. Ammeter. Ammeters are connected how? Series. So does that mean I got to put an ammeter right here and I got to run everything through the ammeter?
No.
What do I do?
After, yeah.
What?
Put it after the load?
After the load? What do you mean?
That doesn't sound right then.
Well, I'm confused. Where's after the load? Like on this side?
Where are you pointing?
To the negative plate?
No.
Well, I want to know what's going in and out of the battery. Where am I going to put it?
Where did it go before the first bus bar?
Right up here?
Before the clock in the Hobbs,
Right here?
Fast and Furious?
Right there, right in that area?
Before, yes.
Let's see.
In between that and the battery and the
Right
bus
here?
bar, yes, that little,
Oh, so that I get the load going to these two things?
to get it before that.
Yeah.
Okay, so your point, yes, but those are extremely minuscule. I mean, how much amps does a clock actually take? But maybe electrically it is that. I don't think so because it's actually, those wires come off and go, run even separate. So,
Okay.
so if I put the amp meter here, would this in fact tell me? Would this tell me the electrical current going into and out of the battery?
Yes.
Okay, but that means then I have to run the entire, this big fat wire to a big fat ammeter and then out of the ammeter, right? Okay, there's another way to do this. And I didn't realize I'm almost out of time. And that is using a shunt. Like shunt to the front door. Okay, which is actually, we can get out another time. But anyway, you're using a resistor basically that has very low resistance, and then you can use a voltmeter to measure the drop on that. And then instead of putting volts on this, just write amps and calibrate it so that it's reading in amps. So anyway, maybe that's for another day. So,
What?
We lost us.
okay. You're going to get to this project. I'll slow down a little bit. I'm going to slow down a little bit. Okay. If I have, let's do something you recognize. Remember this project?
Yes.
Okay. If I want to know how much current is flowing through here, what do I have to do? Disconnect it and put a what? Now all of the current has to flow through the ammeter. And your Simpson meter can only handle how many amps? 10. So I want in my airplane an ammeter that is not much bigger around than my watch. And I want it to read up to 30 amps. Wish me luck? Okay. There's another way to do this. If I want to know, this doesn't work,